All right, Algebra 2 friends, we are going to deal with synthetic division today. You have mastered and gone through long division, and there's a little thing I should probably tell you. Sometimes, under the right circumstances, we don't have to do long division. Sorry about that. Um, but you didn't know that before, so you weren't upset until right now. Sorry. So what it has to be is you have to have a binomial that you're dividing by, and we need to have a lead coefficient of 1, and we're going to make sure that's positive 1. Okay, so when we're dividing by a binomial that starts with 1x to the first power, then we're in a good shape. We can do that. Okay, here's how it works. So I'm going to take, if I get x plus 2, I'm going to draw a backwards L, and I'm going to use -2, right? So that's the first thing is we're going to use solutions or opposite, whichever way you want to think about it, but we're going to be using those solutions or opposites to go right in here. After that, I'm going to take a look at the thing that we need to divide, right? This is the thing that would be inside the dividend. And I'm only going to care about the fact that it's in order, right? 3, 2, 1, and then no x's at all. But I only care about the coefficient. So here we go, 1, -14, 51, and -54, if I can write that in order, 54. Right, I'm going to leave one space here and then put a big plus sign right here. Right, we flip the sign, so instead of having to do that long division subtraction, I could use some addition. So here's how it works. First number, we are going to drop down exactly what it is, 1. Pretty cool so far, right? Yeah, like, yeah, whatever, just do the answer, okay? All right, so now what we're going to do is we're going to work in kind of this V shape right here. So I'm going to do -2 times 1, and that gives me -2. Not too bad. What do I do in this line? I add them together. I get -16. I'm going to do -2 times -16, and I'm going to get 32. So that goes here. What do I do? I'm going to add them. So I get 30. I get 83. 83. All right. So now we're going to go -2 times 83. So it'll be -166. We're going to add them. So I get a 0 here, carry that. I get -220. I'm like, that's great, but I thought we were supposed to get like a polynomial or something. I'm like, yeah, we totally are. Okay, so here's how it works. The last step, we need this started with x to the third power. Our answer is going to be 1 less. This is 1x squared minus 16x to the first plus 83, no x's. So this must be my remainder. So we're going to write plus -220 over top of x plus 2 for the remainder. And we have just divided it. Not too shabby, right? Synthetic division. Okay, it wasn't keeping it from you, right? We have to be able to do long division because if it's a trinomial, if it's x squared, if it's even 2x minus 1, right, we can't do this just yet. Okay, so let's try it in this little shadow box, right? I went to the beach and I collected all these shells and little gems. It was amazing. Okay, that was all make-believe, but it sounds like it'd be really fun because, you know, none of us have gone anywhere for quite some time. And you're thinking, you said to do synthetic division. Now you're talking about the beach, but I only see something to divide. Well, down here in the picture is what we have. So if that's x plus 5, remember we're going to use -5. Coefficients, 1, 7, -38, -240. All right, we're supposed to find the volume of this shadow box. So they showed me the width of the whole thing. So I really hope that I don't get a remainder this time. That way I can find out some other dimensions. But let's see what happens, right? So we got everything set up. Opposite of the binomial. The coefficients in order. Drop the first one. -5. We got 2 when we add, right? So I did -5 times 1 to get this -5. I added to get 2. -5 times 2 is -10. So I'm going to get -48. And let me just confirm here. -48 times -5. So 5 times 48. Guess what, guys? it's going to be positive 240. I'm so excited because when I add this together, it gets 0, right? This is supposed to be my remainder item, and that means the whole thing worked out. So instead of rewriting everything, right, we can fill in x cubed. So we'll go x squared plus 2x equals, I'm sorry, not equals, minus 48. Now, we have one dimension was given. This, my friends, should be factorable, x and x. What factors of 48 are 2 apart? Well, that's 6 and 8. Everybody knows that. Or if they thought about it, they could figure it out. And we want positive 2 out of those. So positive 2 minus 8. So what are the dimensions of the shadow box? It would be x minus 6, x plus 8, and x plus 5. All right, so kind of a weird way, right? We would really like to say that it's like 5 inches wide, 2 inches deep, and like 11 inches tall. But hey, it's algebra 2, right? We're trying to find like weird ways to make this look like something you could use later on. All right, so the remainder theorem, we kind of talked about this before. If you end up with a remainder, right? So this one worked out, right? So that means if I did x plus 5 times this whole thing, right? This x squared plus 2x minus 48, that would give me what we started with. And this one, if I multiplied these together, and by these I mean this trinomial here with what we're dividing by, right? I would still have to subtract negative 220 to equal up what we started with. So, but there's got to be, right? If we're showing shorter ways to do this, there's got to be another one. So the remainder theorem says that if you plug the value in, right? And by value, I mean the solution, right? So notice the sign has changed. So this goes along with synthetic division. That's why we kept it until now. Whatever I get for that number should be the same as the remainder. So here's how we do it. So first things first, let's take 3 and plug it in. So 3 to the 5th minus 2 times 3 to the 3rd minus 3 squared plus 2. Okay, so you might need to grab your calculator here for 3 to the 5th, because I'm going to. Okay, so 243. All right, so we got negative 2. This is 27. So minus 54. 3 squared, that's just minus 9 and plus 2. Okay, so now I might just run through the whole thing. So do 243 minus 54. So it's 189. And then I go minus 9. And I get 180. And then plus 2. So 182. And you're like, oh, that's great. What in the world does all that mean? Okay, so that means if I used 3 here, and I used x to the 5th power, 1, x to the 4th power doesn't exist, x to the 3rd power is negative 2, x to the 2nd power is negative 1, x to the 1st power wasn't in the problem, so there's another 0, and then plus 2 on the end. Oh man, this is a really big polynomial here, right? All right, so let's run through it. Are you ready to go a little bit faster this time? If not, play this in half speed. Drop it, 1. 1 times 3 is 3. Add it, 3. 3 times 3 is 9. Add it, 7. 7 times 3 is 21. Add it to get 20. 3 times 20 is 60. Add it to get 60. 3 times 60 is 180. And add it to get 182. The remainder is 182. We said that it should be 182. Okay, so this is a quick way to double check just by plugging that in. Okay, and we can play around with your calculator and show you a little bit more of how you can get the calculator to do this to find out what the remainder is. And that way you can check all the time whether this was done correctly or not. Okay, obviously if I want to go back here to fill out a final answer, right, it's not what was required here, but we only did 2 examples. So if it starts with x to the 5th, I need 1 less than that. X to the 4th plus x cubed plus x squared plus x plus 60. And then we rewrite this as 182 over top of x minus 3 for that last term. All right, so that's our synthetic division along with the actual remainder theorem. And I'm going to divide up some more of these problems down here for synthetic division and to try them out. And yeah, I'll put them right over here underneath all this stuff. in your notebook. If you're not in my class, then that doesn't mean anything to you. All right. See you later.